Okay.
Welcome, everybody. My name is Forrest, Job Placement Director here at the Tech Academy. Welcome to our Friday Tech Talk. Today we are joined by Wesley Rolfson. He is going to be talking about SQL queries with us today. SQL might be something you've gone over in your boot camp at this point. Maybe it's new to you. Either way, this will be really a valuable experience and exposure to SQL. It's going to have a little demonstration for us, it sounds like, and possibly a presentation. But I won't stall any longer. Wesley, if you want to go ahead and take it away, you are welcome to start with your topic.
Okay. So can you guys see my screen?
Yep, we got it.
All right. Yeah. So like I said, talking about SQL processing and just some of the basics to go over real quick, and then to go into some more how to build more complex solutions. So we're going to talk about what the actual challenge is with SQL, and then the dimensions of SQL, syntax, the three different ways that you can think about it, and then go over what a simple logical query would look like, and then add in some complexity. And we'll end with a subquery challenge, which is just combining all the different parts to come up with a solution to a common business problem. So a lot of times when you go onto like Hacker Rank or something, and you're trying to come up with a good solution to their problem, it seems like it can be a little overwhelming at times, and a lot of that has to do with how you think about the instructions you're trying to write. And so this is kind of an example of how in the directions, or how you tell the SQL processing engine to do something, can matter. The order is important, and the directions you give are pretty essential. So if you told someone to follow these directions, and I mean you could sit down and try to do a bunch of different activities around following directions, and that's pretty much what we're telling SQL to do, is follow my directions and give me a result. You can get a whole bunch of different answers depending on how you how it perceives your instructions. So a lot of times what you'll get just kind of depends on the optimization engine in the background, and how good you were at giving very precise instructions. For instance, maybe the end goal was to get the green one, but you keep getting a bunch of different ones, and the process of going backwards and trying to find out what step that the SQL is not getting right can take quite a bit of time. And the actual result actually looks quite different. It's a chair, and it's hard for people to think like this, and it's also hard for SQL to always interpret everything the way that you thought it was going to do it. And that's why we're talking about the processing order. So everyone's familiar with like a common SQL query. We always start at the top, and we put select, and we say what kinds of things we want it to give us at the end. And then we tell it where to look for the data, which table, and we give it some conditions. I don't want any of the data to have heights less than 5.6 feet. Well, and I want you to group everything by first name. This query seems like it should work. Then order it by the count number, the count of something. Well, that's actually won't work. There's something missing. One, the way that SQL processes this is going to get in the way, and two, we're calling on things that it doesn't know about yet. It doesn't understand some of the different things we're asking, and it's going to be fairly confusing. And on the other side of this whole thing is a query processor, which I've got diagrammed out over here. This is a common diagram, and it's optimizing your query for you and trying to come up with what it thinks might be the best way to do it. And it can get stopped in any one of the different points and come across an error. And so it is important to understand what it's actually doing in between what I tell it to do and what the optimizer and the actual end result will be. So, for instance, the first thing it's going to do is go find all of the data in the team A table and try to process that. It's not going to look it's not going to start out by just eliminating everything that's not in this select statement. It will go to the table first. So this is kind of what we're talking about. So the first thing we do when we talk about logical processing, which is that's what I was gonna tell you guys. Sorry. So lexical processing is what we type on into the query engine ourselves. Logical processing is what SQL's basic understanding of what you might be trying to do is. It's going to go in a certain order, the logical order for it to process your query. And then the actual syntax, what it actually does when you send it all the information, is determined by another part of SQL in the background that's actually optimizing your query based on what it thinks might be the best way based on CPU power and available memory, just to kind of speed the process up. And it can be a little bit of a black box, and so we're not really going to go into a lot of detail on how it's deciding. This is part of that diagram for how that might happen. So again, the first thing that the logical processing goes through is the from, and that's because it needs to start with something, and that something is actually the table of data that you've given it, and it actually grabs all of that data. It doesn't have any limits at this point. So if you were to just type from and then select everything, that would be the same thing at this point. No matter what query you generate, you can simulate what it would show you at this point just by putting select star into that space. The next thing it does is it tries to join all of the tables from the from clause together in some way. And it can be very confusing and a lot of convoluted methods of trying to get that to what you want at the end. But the main point right here is that it's going to do that as a part of the from clause. It's not going to do anything else yet. It's just going to try to come up with a basic table that it's going to operate off of for everything else that you ask. The next step in the process of logical processing is actually the where clause. And this is where we're going to filter out by columns and by specific rows. And we'll go into an example. But a good one would be saying where all names start with the letter A. So if I was processing a table that included the column named name, it would eliminate all of the rows that don't have the letter A in the first character in it. And it would just go forward from there. The next step in logical processing is actually group by. We haven't even gotten to select yet. And group by is taking all of our rows and is grouping them by similar values. So if it was by names, everyone who had the name Adam would be grouped together, and everyone who had the name Brent would get grouped together, and so on and so forth. And in the other columns, you would still see values. They just, when you refer to them, you wouldn't be able to do anything really specific with them at this point. It just has basically grouped them together, like group by. The next step is aggregation. And this actually can be a little bit confusing because a lot of times when we do aggregation, we see that up in select. But this is actually the part of processing where we want to find the min, max, of a value, count how many of something there is, find what the average is, or a mean or a median. This is the part of logical processing that allows us to, that actually is addressing that. And that's important because everything else kind of depends on the aggregations already being done. And that's also something we need to pay attention to when we use group by, because that aggregation and group by happen close together for a similar reason. They're both sort of aggregating data. And once we've got to this step, if we include an aggregation or a group by, we no longer are really able to refer to individual rows in the same way that we were before this point. And then halving happens after aggregation, because halving actually is a way of filtering our data by what we've already aggregated. By finding the min, the max, the average, the count of something, we can actually utilize that to eliminate data or rows or groupings just by an aggregation, which if you tried to do anything like that before, it wouldn't work. You can't use aggregations in where. It's going row by row, and so it wouldn't really understand what you were asking of it because it hasn't done any of the aggregation yet. And then we're going to go back up to the first thing that we wrote, which was our select statement. And the select statement includes what information we want in our set at the end of the entire process of processing the query. These are the things that we're asking it to generate in a table, or what is actually just called a set, or the results. And then some of the different SQL programs will allow you to create something called distinct, which is looking for unique values from the things that you've selected and only displaying the ones that would be considered unique. And that's something that we can talk further about, but it does have some fairly unique applications. Not every SQL program will actually utilize distinct. And the same is going to be true for top. So I'm going to say for top. And then one of the last things we're going to do is order by. And this is important because a lot of people have the understanding that if I run this query once, I'll get one set of results, and then every time after that, I'm going to keep getting it. Well, that's actually not true. The SQL engine doesn't necessarily put things in any specific order, and some of the things we've done as we've gone through the different steps of creating our query and processing it actually are fairly ambiguous on whether or not they're going to put something first or second or third or fourth. There isn't really order in the SQL processing at this point. Only when we use order by that we can guarantee that there is at least some level of organization in the result we're about to get. And then the very last thing that it will do is it'll apply a top, or in other languages, it'll say limit or row num. And that's just saying maybe I have 4,000 results, but I only want you to give me X number. So, or like the top 5. For people who are familiar with Python, that would be like typing head and giving it how many. It's not every program, and it's not really a common thing to use top. We just include it because it is a way to quickly look at a portion of your data, not guaranteeing that it's in any order unless you've given it order by, as a way of examining what you've got. So simple logic. This is, and again, on the left side of this, on the right side of the screen, we have logical processing order, so we can keep track of what we think is going to happen. So what is your favorite color for the presentation attendees that are seeking a job? So your boss walks up to you and he asks you this question, some questions you might have about why. And that's because they want to know who they're going to try to approach for a position. This is how they're going to decide. not really the most equitable, doesn't have anything to do with their skills, but apparently favorite color has some meaning to your boss. So we're gonna use that. So you sent out a survey to everybody attending your meetup, and you decide to query it. You're gonna do it. You're gonna use SQL to do it. So first thing we need to know is we wanted to make sure that we have attendees, okay, and we have their favorite color. We're also going to look at the table. We want it to be the presentation table, which I didn't highlight it in here, but that's the name of the table. And where we want to make sure that they're looking for a job. That could be, that's really important. And we want to know what their favorite color is. And this is the syntax for writing out our query. And then we want to put it in an order just so that we get the same result every time. So, and I didn't write this one into the SQL engine because it's pretty simple, and I have a lot more complicated table we're going to use later. So here's the first thing that happens. When it runs the from clause, it generates this table. And keep in mind, there are 123 actual entries in the table. This is just a portion of it that would fit on our screen. And sometimes programs will do that. They'll cut it off, even though there's more results. You can scroll down and see more. From this table, what do we think is going to happen next? We wanted to narrow it down. This kind of makes sense if you think about processing and trying to be efficient with our time. The reason why it goes to the where clause next is because this is an opportunity to reduce the amount of calculations that are coming next for the CPU. And so we're going to use the where clause to eliminate rows that don't meet our criteria. So seeking all the ones that say they're looking for a job and they don't like the color black. So your boss does not like the color black. So we're going to get rid of everybody who said that they like black. That turns out there are a lot more people on here than you can see. And again, this is why it's important to understand that just because this is what it's showing you, if the program might cut you off and say like this is all there is, you still want to make sure that your query is written as bulletproof. It doesn't depend on how big your screen is or other settings and for like displaying results. So this one actually is going to generate a smaller table. Now it doesn't have anybody who likes the color black anymore, and it doesn't have anybody who's seeking the meetup for their work or for education or just for a hobby. It's just now we're basically looking at everybody who wants to have a job and nobody who likes the color black. And so we've cut down the list quite a bit. And keep in mind, this is generated just by changing the select to say, show me all the results at this point. And then each time, that's how you can do this as you build it, is just change this to say, select all, which is the asterisk. And then as you go from the where clause, now we're going to see what the select says. Here's the select statement being ran. What we see again is we've eliminated not the rows this time, but the columns. And we now have a set or a table of data that represents who we should let our boss know about who attended our meeting. There's a lot of people who like blue and brown, coincidentally, who happen to meet that criteria. So from there, this is in no order really. And this order could change. If I ran this on my system, if you ran it on yours, this list could look very different depending on what SQL engine you run and your settings. So we want to make sure it's the same so I can give this to my boss and they can do the same query just to check on me. So we're going to do the order by next. And when I do the order by, I told it to do it in a descending order. In Postgre, that means starting at the beginning of the alphabet and go to the end of the alphabet. And this is the result we get. And this query is fairly simple, but it does follow logical processing, and that is how it's working. Basically, it's working in the background. It's running in a specific order to generate our queries for us. So let's throw in joins. So it's important to understand every single time you use a join, no matter which kind, the first thing it does is actually our Cartesian product. It multiplies, or in the case of databases, it combines them one for one. So for every entry in table A, we're going to add an entry of table B. So you can see that we basically went through and added all of the things from table A now have an orange juice, a tea drink, and a coffee. And that is where it starts. So the same thing is sort of like with the simple query. The first thing it does is generates a very large set of data to process. And then the next step is actually to use a qualification to reduce that back down again. And that's why when we're talking about joins, we try to make sure that we think about things in pairs. So one table being combined with another table, and as things get more complicated, we try to keep that same perspective because it's going to be helpful trying to keep track of what information is getting included and excluded at each step. So this is another example, and this is a full outer join. It's going to combine on our qualification, which we said was ID. And we're saying these two are the same. So for every pair that's the same, those two are the same, it's going to generate, like this diagram shows, all of the columns and then fill them in with the data that's that matches between the two of them as it goes down. And that includes the fact that there isn't a fourth row in table on the left table, so that it's going to fill them in with null. And it's important that we know that it did that, because a null has very specific values depending on how we use it. In this case, does anyone know why it picked what this null is going to mean as compared to other reasons why we might put null onto here? Like why did it say this is a null value? It's null because it doesn't actually have anything in it. There is no value, as in we don't know a date, the country, or the units. So it's unknown at this point. And so here are the different types of joins. If you look at the various types of joins, we have a left join, a full outer join. Each of the different circles is representing kind of like what does that join mean, is going to happen at what's the result of this join. And again, that's why we try to think about things in groups of two, is because it's a little bit easier for us to process. But it's also important to pay attention to which direction, left or right, full, inner, outer, as we go, and to help us come up with the plan of like what data do we want. Like if there's a big difference between a full outer and an inner join, and so we would want to make sure that we're picking our joins to match the plan. And a lot of times you'll see we'll use the select statement again, or the select clause, to show us like what is that result before we move on to the next step in the process, as we try to work out, process what's going on. Like I said, we try to see complex joins, like multiple joins, or stacked joins, as some people would say, as just the pairs. So processing one set over another. This is a good example of why we want to pay attention to chiastic order as well, which is just means that as things are layered on top of each other, it's important to pay attention to what are we actually saying. So there's a big difference between these two. In this one, it's all inner, and we most likely what we wanted was to say the things that are start with A and B. We want to have an inner join of A and B, and then we want to also do an inner join off of A and C. Well, to do that, we want to make sure that we're not incorporating. We want to put A and B or A and C inside of parentheses, or write it in chiastic order so that we can see the difference as we go, of which things are going to be joined with which. And that's definitely very different. And this is what chiastic order can look like. For this same exact example, you'll notice that the inner join for A to B and C is actually written in this way. So we combined A and B, and we've combined B and C, and the on clause, this part here, comes after the inner join of this pair and this pair and this pair. We're always leaving the ons on the bottom, and this is written in a way so that we can actually keep track, and also it's actually more efficient as you go in and out of the different joins.
Is the indentation important on a chiastic order, or is that just to show?
It's to help you to see what you're doing. Like when you write code, also for other people too, because it can get really confusing. Like the normal way to write that would be to put the on up here, and then you'd have to be putting things in parentheses. And I don't know about you, but tracking parentheses can be hard. So even if I'm doing parentheses, the version where I just do parentheses the whole way down, I still indent, because it does help someone else track the joins as we go. And that's kind of a common practice in programming, is to use indentation to indicate, like, this is a sub process of something else. And so we try to do that as much as possible. And there's a look at this one. This one's actually even more complicated. There's one more layer. I didn't realize but it still is the chiastic order example, which is to always make sure the most inner one, which is probably what they wrote last, even though it looks like, they wrote it in this order. They probably wrote this one, and then they put A to B together. Like I said, always focusing on two tables and not all four. And then once you've combined A and B, you know that you're going to combine it with C. So then write the next level and keep doing that. And this actually is fairly clean. The more complicated version has a lot of parentheses, and it is hard to follow. So I've gone away from doing that, and I mostly do this in almost all my programming, is to indent as far as I possibly can and then come back out again. And since it's such a common practice, I think people understand it a little bit better. And that is kind of a problem as a business, is you want your code to live longer than your employee so that they can actually reuse it.
One follow-up question to that. Sorry to interrupt again.
Sure.
Is the blue, the first one, the A on B, is that happening first, and then the green one's happening, and then the orange one, in that order? Or? Okay,
so in logical processing, there's no guarantee that it's going to go in that order. More likely, I'm forcing it to do C and D, B and C, A and B. Because if you just put these all in a row and let them all go, the problem is that now the third layer, the actual optimizing engine, could decide that the most efficient way to do it is to combine A and C, and B comes in there, and then you just it gets really confused. And an example that they'll use is if you tell it to join and something is in A which is not in B, it might join with C, which shares data with A still, and now you have a problem where you're expecting 100 results and you only get 4. And it's because the first time you joined, it decided to do it out of the order you thought it was going to do, and now it's eliminating rows as it goes. So forcing it into this order is more helpful for you to see, and it's also helpful for the logical processing to go on to work off of. And then again, once you get to the actual processing level, it figures it out, but it's still constrained by how you wrote it. It will limit it some. But it might decide that based on everything you've done, it's easier just to join A and C still. That there is some confusion about what it would do with as you get further and further down into inner joins, specifically inner joins.
That's helpful. Thank you. I appreciate it.
Yeah. So, we went through. So, and then one thing to remember is, so they're separated out as from and join, but as soon as you finish your joins, and again, they can be very convoluted, and it's important to always work them in pairs to try to figure out like what is it actually doing as it's eliminating rows and filling in null values in different places. You'd want to just think about that at the end. This is really just the from clause again. It just processes the same at that point. And the next step is always to go to where. If there are no where clauses, then it would jump down the list and try to find the next one to work on. But when you do have a where clause, this is where we can eliminate rows based on the values in specific columns. And you can get pretty complex. You can say things like eliminate all names that don't start with A, and anyone who doesn't like the color gray, and breeds who are hairy breeds of cats. You can go really detailed in your where clause, and that's important to think about. If you get down to the end and you're trying to figure out how to optimize your queries from just the lexical side of it, as we go into logical processing, is to use the where as a way to fine-tune your query just a little bit more, because the more rows I can eliminate, the more columns I can eliminate before I get to the select clause, the better. So our goal is to get as many things that we don't want it to work to process out of the way, because the problem is before optimizers, it would literally go through your entire database trying to find all of the things that match its criteria, all of the qualifiers, and that is time and memory. It's a big waste of time. You can go a lot quicker if you can get rid of more things more quickly, which is why there's logical processing, so you can, one, understand how it's working, and two, so you can try to figure out what things are easier to get rid of early. And so that's where where comes in. Things to pay attention to: null values. They either mean we don't know, or they mean that it's not an applicable thing. We don't have fur, so if we include animals in a table and you get to people, every person that you add to the database will have null for their fur value. Like there's no pattern to our fur. We don't have it. So you can't say that it's unknown. We literally just don't have fur. Whereas maybe you don't know what the fur pattern is on a dog because you've never seen it. There's no picture. That data is missing. That's different. And so you need to know that when you get to the where clause, because that can help you decide if you're going to address them or if you're going to ignore them as a potential. And you might have to address them, and which is why there's a thing called is not and is. And not every SQL engine, SQL program handles this the same. And ANSI SQL standards have changed, and they're getting better to address nulls. When I can't remember the name of the guy, there was a gentleman, I think back in the 50s, he realized this was a problem, and we should include null. And then quickly found out that we went from being able to use binary logic, is something something, or is it not something? We can do that fairly well. We can ask it to eliminate everything that is red, and we can tell it to include everything that is red. But nulls don't work that way, because nulls actually mean two different things. Like I just said, it's either an unknown thing or it doesn't apply to it. And that doesn't really work for SQL. It doesn't quite understand that how that should work. So they came up with is not and is. And we use this with null quite a bit because we want to make sure that we account for it in our where clause. And I think I have an example of it in our challenge. So the other thing you need to remember is you cannot refer to aggregates or an alias in this that you're going to use in the select statement while you're using where, because it hasn't done that yet. There are no aggregates yet. So referring to it, even though you are going to type it into the select line, it still will not know what to do with it, and you will get an error. So there are ways of getting around that, and we can talk about that. We'll talk about that in a little while. But it is important to remember, if you use the where clause, you can't use an alias because it doesn't exist yet. The processor doesn't know, and you can't refer to averages, min, max, mean. You can't do count. It won't work. It doesn't know it. You haven't created them yet in its eyes. It hasn't seen them come through. So, like I said, you should use the where clause to remove all of the individual rows you can. If you already know that you're not going to process any pets who are from a foreign country, this would be the time to eliminate them. If you're not going to work with cats, get the cats out of here now. Do it as early as you can in the process. And the where clause is a great way to do that. So filters and aggregates, again, this is the same thing. Using where to filter and aggregates reduces the amount of information. That's what we're going to talk about. And since you don't necessarily need every single value, if you're just looking for an average, this is, again, going to help you. We can figure out a whole bunch of different ways to eliminate rows using filters and aggregates. But you have to pay attention to references to columns and referring to aggregates in your group by having and where, because if it hasn't been processed yet, you can't use it. So like you can't use any of the group by groups in the where. You can't. Having group by and where do not like aggregates. And this is another example of, once I start using aggregates, I have to pay attention to something else, which is, so what I want is, I want it to tell me the name and the count of everything. And we're going to call that column now is going to be called count. Well, the problem is I just asked it to tell me how many names there are in the name column. And then I said, tell me every name. And so the database or the SQL processor doesn't know what to do with that. And it's going to tell you that you've asked for something that's inside of an aggregate. And you can't do that. You can either ask it for how many of something, or you can tell it to provide you a list of all of the things that are that something. And so again, that's important. As you're making your queries, you want to make sure that you're actually paying attention if whenever you ask for an aggregate, like min, max, average, or account, and there's more examples, you want to make sure you also don't then turn around and say, hey, can you also tell me all of the contents of that? You might have to do a union, or you might have to come up with another way of addressing that problem. And then once we've done a group by or where, we can go to group by. It's the next step in our logical processing. And really, we're just really talking about grouping all of the rows based on some criteria, like it's usually a column, like a city or a breed of a cat. And the goal being to reduce the information down even further, so that you can create counts of the number of cats, the number of people who are from a specific city. But at the same time, you're not also interested in knowing who those people are who live in that city. You just want to know how many people are either live or are from a specific city. This would be a way to do that without having to go through the process of counting them individually. You can do it using a group by. And then having, which is actually allows us to do something that we might have tried to do with our where clause, which is to create a filter by an aggregation. So you could group everybody by which school they attend, and then you could also say, of those people who attend that school, how many of them are over 5'6". You can do things like that, but you couldn't ask in the where clause how to do that. It wouldn't work. And then you can use any valid predicate. Well, that just means any comparison, like is it equal to this? Does it not equal that? Is it greater than or equal to? And then using the is not and the is. You can use anything like that too in the having as well. And you'll have to pay attention to null values again, because they will come up. So the last thing in a simple SQL query is a select statement. While it is processed, you do it last. This is actually the thing where this is actually something you can be using as you're creating your query to check that it's processing like you want. Like for instance, when you add your group by in, and I kind of recommend following this order with the exception of the select clause. I would write my from, my join, my where, my group in that order. And as I'm going, I'm putting in select star to actually allow us to see what results we're getting as we go. It can be time saving, and it can help you identify some errors as you go, especially when you are dealing with aggregates and trying to make sure that you're not trying to generate lists and aggregates. You're not trying to call on something you haven't created yet. You'll be able to see fairly quickly. And again, this is another place where we're actually filtering, but this time we're filtering by columns, columns, aliases, and aggregates. And what comes out of the select statement is actually a result set. And the reason why we need to use an order by, or we choose to use order bys, is because until you apply an order, there isn't really a guarantee that the SQL engine is going to generate the results in the way that you want them. It doesn't have, the data is not stored in an order based on your query. It might be stored in order based on an ID, but that again still isn't a solid way for you to reference your data, and you may not even include that in your query, so you're not going to gain that as a way of structuring your data. Instead, you need to use order by, and order by actually requires you sometimes to use tiebreakers or just additional things to organize it by. So you might start out saying, I want to organize everything by species, and then by the color, and then by their breed, and then by where they got a vaccination, just to kind of create the structure that you're looking for. If you don't care about the order of something, you're not going to be including it. But if you do, if you want your results to always be the same every single time you run it, it's important to include everything that you want to remain solid in the order of your order by. And the other thing you need to pay attention to is nulls again. Nulls are probably one of the most annoying things about writing queries. Is nulls tend to throw you loops. And it's because you don't really know if it's an unknown value or if it's just not present. And how each of the different engines processes a null can affect the way your results look. Like Postgre, SQL, and Oracle, nulls are considered the highest possible value of whatever you try to order it as. And whereas MySQL and SQL Server both do the opposite. They're the lowest possible value in the system. So you would get different results depending on which of the engines you're using to run your queries. And then the last thing we're going to talk about is top or limits, and then row num. Again, those are things that are program specific. Row num is for Postgre, and it really is just allowing you to say, I only want to see so many results. I don't really want everything. I just want like 5 of them, or I only want 10. But again, what 10 you get is dependent on order. So if you're really determined to produce the same exact result every time, you want to make sure that you're also using order by as a part of it. And then the last thing that I wanted to talk about is select distinct. That's not available for everybody who uses SQL. Postgre can use select distinct, and not everybody, not all the rest of them. Some of them are kind of catching up. And so you will see this, but this is a way to aggregate based on unique values. So if you have a bunch of names in a list that's really long, and you just want to know the names that do exist, and you want to collect some data about them in general, you could tell the SQL server, I want it to create select distinct to create all of the unique values for a given query. So everything I put after that is going to produce a singular. If it has multiples of a value, it's just going to show you one of them, and then it's going to handle some of the other data just in kind of like a very ambiguous way. You're not really going to know how it's going to pick that value. Some of the engines pick the first value they come across. Others use a different process, and the optimizer plays a big part in that. So, and for the most part, I would try to avoid using distinct clauses unless you absolutely have to, because it does affect the results. And since we're trying to be fairly accurate, I would probably come up with a different way of grouping by, or using other clauses to find what you're looking for. Because again, it aggregates. So everything you give it, it has to decide how it's going to interpret the differences in values. And we'll probably see that in our challenge. So, does anyone have any questions before we do the challenge? It's a little complicated, and I'll have to show you some of the database to do it as well.
I've got a couple, but I think since we're running a little bit closer to the end, we probably should just jump straight to the challenge, just to make sure we've got enough time to get through it.
Okay, so our goal is to find the number of vaccinations each animal has received, to include animals that were last vaccinated on or after October 1st of 2019. We want to make sure that we give the name, the species, the primary color, the breed, and the number of vaccinations. And so, let's find SQL. So let's show you our tables. So we have, whoops, that one down. So we have tables that have adoptions, animals, persons, staff. There's lots of really complicated levels to this database. And I got this one from someone who, he made his own because he got tired of using the bikes example. And it's actually really thorough. So that's why I chose it, because I really liked being able to make some complex queries. So the first thing we wanted to do, let's see if I'll pull up the other side of it too. Oops, it goes. There. So we need to know a couple of things, and without knowing everything about all the different databases, we know that we're going to need to know about animals. So I'll give you that, and you'll need the vaccinations. Just guessing. And so far, that is where we're at. And we can't just use them like this. We're going to have to do something. So I just put them in here to remind myself that that's what we're going to be using. And we can use our select to peek at them. And I'll show you guys the answer that we come up with off of the other petition. So this is, I forgot one. That's funny. Just lost me. Oh. My server disconnected.
I don't think it wants.
It's been giving me trouble today. But anyway,
Can you hit the parentheses?
I usually do. There we go. So you can see, like, this is fairly typical for the animals, and to make it work, we'll need to alias it. We're going to give it a name, A. And
As a.
yep. And then left, we're going to do a left outer join. And we're going to do vaccinations as V. Although, and I like to do all lowercase except for the actual commands that are from SQL. So and aliases. Yeah. Then we're going to do Um, I'll show you the other one. Any trouble today? In vaccinations, has the same exact name and species and everything that lines up. So we can use v.name for our join, and we're going to tell it we want it to map to name in animals, and we want it also because we're dealing with different species. We also would want to try to use species as well because we're going to use it. We're going to use species in our final set. Yeah, there we go. So that should be our two tables. Okay. And then we're trying to find all of the species. Primary color, breed, number of vaccinations. So I happen to know, we're not going to use a where yet, but we
Animals last vaccinated on or after.
Yeah. Okay, so what do you think we're gonna what should we filter out?
Vaccination time.
Okay. And so the way that they wrote it is actually going to have to be, it's actually a little bit more tricky than that. And so that number is actually 2019. So you have to write the year in this format or it won't work. Okay. Anything else we want to filter out? Okay. Next. And that one, so it messes up. We do need a group by, which is our next processing step. And what do we want to group by?
Either the animal or the amount of
I think we're actually,
or is it the number of X? Oh, I see.
so we wanted to tell us specifically for each animal, but we could tell it, we can be more specific. You could tell it by breed. At this point, let me do that. No group by, and then the next step, what's our next step in the processing? Do you remember?
Is it order?
It is not order.
Aggregations.
Is aggregation. Yep. So, and your aggregates are so we need to do count of something. You're going to do the number of vaccinations. And we happen to know what we want to do. So where are we going to get vaccinations from? They're in the vaccine. They're underneath this one. And we want to name it something because it'll just give it, so we'll just say num vac. Okay. And what else do we need here? We also need the name, species, primary color, breed. All right. Name. Breed. And then I think you want to notify. Let's check our names on our animal. So something didn't work. Why is it not working?
Name appears on both of your joins.
Yeah,
So you'd have to specify which ones you're taking the names from
yeah. I
in
think that's
select.
the last one. Yep, so you got to add A's and V's to everything just to be safe. It's a good practice to get in when we make those to specify. The other thing is to make sure that if you're going to use them inside of a subquery, then you would then also want to make sure that you're using the same process. Everything has A's and V's. And now I think there's only one that I missed. Like, again, no. I love it. Why?
Didn't aggregation.
Hmm?
No, somebody didn't appear and wants it in a group by.
Yep. So if we do this, and we change, I think it's this one. Yes. So we're gonna do max primary color. You have to do max breed. And we're gonna tell this one is color. This one is as breed. Let's do that again. And okay, that might help more. And now we can actually use this to help fix our problem. Time 9. Oops. 1. And yeah, that might help.
Is it because of the semicolon on the end of the order by?
There you go. Almost. Getting there. And we have to do something else, which we always have to deal with. You have to tell it one other thing. You have to say, what about nulls?
Is not null.
It almost works. Is null works better for some reason. All of the vaccinations that are null have to still come out because because it will fix this problem for us, and we can change it to not null. It will still give me the same problem.
Is it because having is after the order by and it should be between group by
Yay!
and order by?
Good job. That is exactly why. And now it wants me to fix one more thing. I don't remember why that one doesn't work.
Because it doesn't match what you have in the where. You're missing
Like the
one of
date's
the
missing
ones
the
is
one.
wrong. One of the ones in your thing is missing. You got 10,001.
Okay. What?
Oh, is it because there's a less than on the where clause and a or does your greater than less than are backwards?
Yeah. There's an equal that's supposed to be. The question says equal or less.
Right, but I think that it didn't. Well, we can do that. We can do this. It doesn't. It's really gonna. I think if I remember correctly, there's none that are actually right on that day, but maybe. There you go.
Hooray.
Order really matters, and paying attention to aliases is important, along with making sure that as you go, like those are things that are fairly common as you try to write out your query. Oh, I think I just deleted the thing. Yep, I did. I'm a stickler about spacing, but this is the general idea, and the subquery that you generate. I mean, we didn't have time for it. I switched out the example because I didn't realize how long it would then. You can use this to generate things off of persons who are the staff that were working, and what person is the most common adopter. Using all this information, you can generate really cool, crazy reports, but it all has to do with processing order. You need to make sure that you're paying attention, especially when you get into subqueries, because it gets even more confusing. You guys have any questions? And we're like way over now.
That's okay. That was a really educational experience for everybody. I like that it was crazy that each command happens in a different order than what we expect. The select happening kind of last and all that. And it was really interesting having you actually show us that in an example of what's happened, like why you did this one first, and you kind of go back through. I don't know, that was pretty valuable, I would have to say. I don't know if we have a ton of time for questions, but I would like to say thank you very much for this. This was incredibly educational. I know SQL can be a sticking point for a lot of folks, and
I just really recommend as you're preparing to go look for anything that talks about logical processing for your SQL, because it does make a difference. And there is a guy who's on LinkedIn who does LinkedIn Learning, but it's not really accessible to everybody. He does a fairly good job teaching it. And I'm sure that you guys do a really good job of teaching about SQL too. It's just really hard to help people understand why. It makes the most sense when we write it in the order we write it, because it's what comes to our mind. But the SQL processing engines do it differently, and that can help you figure out why isn't my thing working.
Yeah,
but
it seems like a very valuable
talk today, and really appreciate all the presentations you guys put on.
Thank you so much, Wesley. We really appreciate having you here. This was super valuable. Thank you, everybody, for coming. I really appreciate sticking around and hanging out for that. And we hope to see everybody at our next week. I'll be sending out a survey to everybody that came today to get a little bit of feedback on our tech talks. And so keep an eye out on that on your email. But otherwise, I hope everybody has a really safe weekend. And we will see you all at our next tech talk.
Thanks.
Thank you so much, Wesley.
Yep.